Okay, I want to continue our examples now on adding and subtracting rational expressions when the denominators are different. All right, so here's a subtraction problem. We have 6 over x squared minus 2x minus 8 minus 1 over x squared plus 3x plus 2. So our task is to subtract them and combine them into a single rational expression and simplify any further if possible, and then also state any possible domain restrictions. Okay, so with a problem like this, the first thing I notice is that the denominators, they're not the same. They're both quadratics that I believe factor. So try to factor. That's the first thing you want to do. Get a sense of what the factors of the denominator are. So I've got 6 over x squared minus 2x minus 8. I want factors of negative 8 that add to negative 2. Well, I'm thinking negative 4 and positive 2, right? Negative 4 plus 2 is negative 2, but negative 4 times 2 is negative 8. Okay, so I have that, and then the second fraction in the denominator there, x squared plus 3x plus 2, factors of 2 that add to 3, 2 and 1, right? So I've got x plus 2 times x plus 1. Okay, now over on the side here, I'm thinking about the LCD. What is the LCD going to be looking at all of this? So start listing the factors. I've got x minus 4. X plus 2 exists in both denominators, but just once, right? So I include it once in the LCD. And then x plus 1 is also there, right? So I'm going to have x plus 1 as part of the LCD. So the LCD is x minus 4 times x plus 2 times x plus 1. All right, so in the first fraction, I have x minus 4 and x plus 2, but I'm lacking the x plus 1, right? So I want to multiply numerator and denominator of that first fraction by x plus 1, right? In the second fraction, I have x plus 2 times x plus 1, and I'm missing, what am I missing? The x minus 4, right? To get to the LCD, I need an x minus 4. All right, so now the numerator, I'm going to have 6 times x plus 1 minus x minus 4, right? That's what the numerators end up being. And then the denominator is x minus 4 times x plus 2 times x plus 1. All right, so now the task is to simplify the numerator. Again, you can't cancel any of those factors yet because you're subtracting those two numerators, the 6 times x plus 1 minus x minus 4. All right, so let's do some simplification in the numerator first. 6x plus 6 minus x plus 4, right? So I distributed the 6 through and I distributed the negative 1 through. And I still have that denominator of x minus 4 times x plus 2 times x plus 1. All right, 6x minus x is 5x. 6 plus 4 is 10. So I have 5x plus 10 over x minus 4 times x plus 2 times x plus 1. The only other thing I can see to do is to factor a 5 out in the numerator. So I'll have 5 times the quantity x plus 2 all over x minus 4 times x plus 2 times x plus 1. Okay, and of course I can cancel out an x plus 2. So that leaves 5 divided by x minus 4 times x plus 1. And of course, because I canceled out the factor of x plus 2, I have to say that x cannot be negative 2, right? Because that would make that factor 0. So hopefully you're getting the idea here in how to find a common denominator and simplify from there. All right, let's do one more. Same directions here, add or subtract the rational expression to a single rational expression and then simplify. And state any domain restrictions if needed. In this example, we have x over x plus 2 minus 2 over x minus 2 plus 3. All right, so there's no factoring to be done, right? The denominators are fully factored. And the first two fractions are the denominators we want to take a look at, right? So the LCD is going to be x plus 2 times x minus 2, right? So we have to include both of those factors in the LCD. The expression or the term of 3, the plus 3 on the end, it doesn't have a denominator, right? But we need to create one because we have to have a common denominator among all of those. So let's take a look here. So what do we have to do to the first fraction to get the LCD to be x plus 2 times x minus 2? We already have an x plus 2 there, but what do we need to multiply that by? X minus 2, right? Numerator and denominator. All right, from there we're going to subtract 2 over x minus 2, and what's missing there? Well, the x plus 2, right? Now, with the 3, I'm adding 3, right? Remember that's 3 over 1, so I need to multiply 3 by x plus 2 times x minus 2 over x plus 2 times x minus 2, right? Because it's missing the entire denominator, right? So I have to create it. All right, so in general, when you're adding a constant on like that, that's how you want to treat it. You're going to multiply it by basically the LCD divided by the LCD, right? Which is still a factor of 1. Okay, so let's go from there and simplify things because I've got a common denominator among all 3 of those terms now. All right, so I'm just going to go without doing any distributing, and you can do the distributing if you want, but I'm just going to leave it alone for a minute. I've got x times x minus 2 minus 2 times x plus 2 plus 3 times x plus 2 times x minus 2, right? All over the common denominator of x minus 2 times x plus 2, right? Okay, so let's work on that numerator a bit. We're going to have x times x minus 2 is x squared minus 2x minus 2x minus 4, right, when I distribute the negative 2 through, plus 3, and I'm going to FOIL the x plus 2 times x minus 2, which is x squared minus 4, right, difference of squares, all over x minus 2 times x plus 2. All right, now I'm going to do that final step before I do any combining here. I'm going to distribute the 3 through, so I'm going to have 3x squared minus 12, right? So in the numerator, I'm going to have x squared minus 2x minus 4 plus 3x squared minus 12, right? And in the denominator, x minus 2 times x plus 2. Let's combine like terms in the numerator. X squared and 3x squared is 4x squared. And negative 2x minus 2x is minus 4x. And negative 4 minus 12 is minus 16. Okay, all over x minus 2 times x plus 2. Okay, so I can see in the numerator if I factor a 4 out, I'm going to have 4 times the quantity x squared minus x minus 4 all over x minus 2 times x plus 2. So factors of negative 4 that add to negative 1, just trying to see if I can factor that numerator a little bit. I don't think we can get there, right? So with a negative 4, we're either going to have 4 and negative 1, which is 3, or negative 4 and positive 1, which is negative 3, or we'd have 2, positive 2 and negative 2, right, which wouldn't get us there. So anyway, it looks like we can simplify this a little bit further, but we can't. Okay, so because we haven't canceled anything out in that final step, that we don't have any hidden domain restrictions, right? There are no domain restrictions in the final result that are different than in the original expression. All right, so I hope you're getting the feel for this, thinking about that LCD, how to build up each term such that it has the LCD so you can actually add and subtract the terms together. And then make sure you simplify and think about the domain restrictions if there are any hidden ones at the end. Okay.